Okay, welcome to another yearly past paper session. Today's paper is November 23 1 2. We will start off immediately and see what questions we have. It is the coefficient of x cube and the expansion of this is 6 times the coefficient of x square and the expansion of that. So there are two different expansions. Okay, so 5c r 3 power 5 minus r. I'm trying to find a specific term in this. So I'm going to say that this is basically x power r here. What I want is x cube, so x cube equals to x power r. And then there's another expansion where it says that 6c2, 6cr, 2 power 6 minus r, and ax power r. Similarly, I have x power r here, and I want the x square term. So I have r equals to 2 from here and r equals to 3 from here. Let's see what the coefficients are. Once I calculate, I will know the coefficients. Okay, I think that should give me 720 a cube x cube, and then 6c2 2 power 6 minus 2 ax power 2. So that's 62 is 15. 15 into 16 is 240. Okay, so 240 a square x square. Now the coefficients of the first one is 6 times the coefficient of the second one. So 720 a cube equals to 6 times 240 a square. So what is 6 times 240? I think that's 1440 a square. So I'll bring everything to one side and say that either a square equals to 0 or so a equals to 2. Okay, moving on, I have find the exact solution. When I say exact, that means my answer has to be in roots and so on. So 1/6 pi plus tan inverse of 4x minus cos inverse of root 3 over 2. Cos inverse of root 3 over 2 is pi over 6. Okay, I think that should, calculator should give you that. Let me check if my calculator is giving me that. My calculator should be in radians. You should know that. Cos inverse of root 3 over 2. Yeah, pi over 6. Okay, so I get pi over 6 plus pi over 6 equals to tan inverse of 4x. 4x equals to tan of 2 pi over 6, which is pi over 3. What is pi tan of pi over 3? Tan of pi over 3 is again from my calculator. That's root 3 equals to 4x. So x should equal root 3 divided by 4. Did I miss out a minus somewhere? No, I didn't miss out a minus anywhere. Root 3 over 4. Okay, yeah, I have made out a minus here because I moved it to the other side. Okay, so let's do this again from here. Okay, so I have minus tan inverse of 4x equals to minus 2 pi over 6, pi over 6, 2 pi over 6. And then I first move the minus, so minus 2 pi over 6 equals to tan inverse of 4x. And then I have tan of minus 2 pi over 6. So that should be minus root 3. Okay, moving on to the next question. This is the equation of a curve is such that dy by dx equals to this. The curve passes through the point. Find the equation of the normal to the curve at P. So dy by dx at x equals to 2, half times 2 plus 72 to power 4. I am trying to find out what? I'm trying to find out the gradient at, so 5.5. Okay, I hope that's the correct gradient for the tangent right now. Okay, that's the gradient of the tangent. Let's talk about uh, tangent is 11 over 2 or 5.5. Gradient of normal is minus 2 over 11. Then y minus y1, m x minus x1. So 11y minus 88 minus 2x plus 4. So I get 11y equals to minus 2x plus 92. Okay, find the equation of the curve. So that is about integration. Let's take dy by dx and integrate that. So I get y equals to x squared over 2 into 2 plus 72x power minus 3 plus 1 minus 4 plus 1. That means minus 3 plus c. How do I find out c? I use x as 2 and y as 8. Okay, so 8 minus 1 minus 72 times 72 divided by minus 3 into 8. I'm getting c as 10. So y becomes x squared over 4 minus 72 divided by 3, 24. Minus 24 over x cubed plus 10. That is indeed the correct answer. Let's move on to the next one. Question number 4 says the diagram shows the shape of a coin. The three arcs AB, BC, and CA are parts of the circle with centers C, A, and B respectively. ABC is an equilateral triangle with sides of length 2. So if I were to draw this triangle, I would get an equilateral one, and each side would be 2, so that this was 60 degrees or pi over 3. Okay, find the perimeter of the coin. So I think those are just arc lengths. So S equals to R theta for one side. So that's 2 into pi over 3. That gives me 2 pi over 3. How many of these do I have? Perimeter is 3 times 2 pi over 3. Gives me 2 pi. Find the area of the face ABC of the coin, giving the answer in terms of pi and root 3. So area is basically a triangle plus 3 segments. So let's first find out the segment. The segment is area of sector minus area of triangle. So area of sector is half, or I could write this in one go. Area of coin is equals to 3 times segment plus area of triangle. The segment is this area. And how do you calculate the segment? You do 3 times area of sector minus area of triangle, and then you add the center area of triangle from the middle, and that should give you your final answer. So what's area of sector? It's half r square theta minus half a b sine of c plus area of triangle, half a b sine of c. Okay, so let's see if we get the correct answer. It's a long calculation. Let me just break that up so that I don't make a silly mistake giving an answer in terms of pi and root 3. So that gives me 2 pi over 3 minus sine pi over 3. Sine 60 is root 3 over 2. So root 3 over 2, that gives me root 3 plus root 3 over 2, that also gives me root 3. So 6 pi over 3 minus 3 root 3 plus root 3. So that's 2 pi minus 2 root 3. I hope that should be the correct answer. Yes, that is indeed the correct answer. The first, second, and third terms of a geometric progression are sine theta, cos theta, and 2 minus sine theta respectively, where theta is in radians, is an acute angle. Find the value of theta. Okay, so first, second, and third terms. Okay, so there must be in a common ratio. So the common ratio should be cos theta over sine theta, term 2 divided by term 1, and 2 minus sine theta divided by cos theta. And these common ratios should be equal. Why? Because a common ratio is consistent across the geometric progression. So I get cos square theta to sine theta minus sine square theta when I cross multiply. That's 1 minus sine square theta. I think this is cancelling out. So I have sine theta equals to 1. 2 sine theta equals to 1. Sine theta equals to half. And theta is sine inverse of half, which is pi over 6 from my calculator. Yep, that is indeed the correct answer. Using this value of theta, find the sum of the first 10 terms. Sum of 10 terms is a 1 minus r power n, or 1 minus r. A was sine theta. Sine theta is half. Okay, so half. R was cos theta divided by sine theta, which is 1 over tan theta. So 1 over tan pi over 3, pi over 6, power 10, and 1 minus 1 over tan pi over 6. Okay, so let's calculate that. I will have to calculate 1 over tan pi over 6 first. Tan pi over 6. It's root 3. The entire thing is root 3. So 1 minus root 3 power 10 over 1 minus root 3. Okay, let's see if I get root 3 power 10 from my calculator. Yeah, root 3 power 10 from my calculator gives me 243. So I am getting minus 242 divided by 2, minus 121 over 1 minus root 3. I want root c here. So what I'm going to do is I'm going to move this negative to the bottom and say that this is 121 over root 3 minus 1. The signs get inverted. Okay, yeah, that is indeed the correct answer. Let's move on. Question 6. It says the equation of a curve is y equals to x square minus 8x plus 5. Find the coordinates of the minimum point of the curve. So dy by dx, that's simple. 2x minus 8. So equate that to 0, 2x minus 8. So x should equal 4. So then y equals to 4 square minus 8 times 4 plus 5. So that's 16 minus 32 plus 5. It's minus 11. So 4 comma minus 11. The curve is stretched by a factor of 2 parallel to the y-axis. So it's a vertical stretch, and that I know is 2f of x. And then translated by for 1. So first I'll calculate 2f of x to find out what 2f of x is. 2f of x is then 2 times x squared minus 16x plus 5. Okay, let's call that g of x. Now this g of x is then it doesn't say I have to find the coordinates of the minimum point of the transform curve. Oh, okay. So I don't need to worry about finding the equation of the curve. I can just use the minimum point. So when I stretch parallel to the y-axis, my y coordinate gets stretched. So it's going to get multiplied by 2. So it's going to become 4 comma minus 22 first. And then I have a translation of 4 and 1. So 4 plus 4 and minus 22 plus 1. So I have 8 comma minus 21, if I am correct. Yes. Then it says find the equation of the transform curve, giving your answer in the form ax squared plus bx plus c, where a, b, c are integers to be found. So the original curve was x squared minus 8x plus 5. So when I stretch it, the new curve, let's call that g of x, is 2x squared minus 16x plus 10. Then when I transform it, what happens is I get the transformation that's going to happen is that I'm going to subtract 4 from x and add 1 because I want a transformation of 4 units to the right, and I want 1 unit up. So what I'm going to do is I am going to replace each of these x's with x minus 4, and then I'm going to add 1 at the end. Okay, so this is now a new function called h of x, let's say. I'm just giving the names, function names, because I want to show you that they're all different functions. It's not necessary. Okay, yep, that is the correct answer. Let's move on. Okay, verify the identity. It's just asking you to verify. So you just start multiplying. You multiply 2x with all of this. So you get 8x cubed plus 4x squared minus 2x. And then I'm writing in the next line so that I can add subtract easily. So I get a total of what? I get 8x cubed, 0x squared. Okay, just cancel that. Minus 4x plus 1. Okay. I don't know why that was necessary here, but let's see. I think it's going to ask you to do something at the end. So sine square theta, tan square theta can be changed into sine square theta over cos square theta plus 1 divided by sine square theta over cos square theta minus 1. So I've changed tan square into sine square over cos square. So cos square theta, I have sine square theta plus cos square theta divided by sine square theta minus cos square theta over cos square theta. Okay, so that's 1 over cos square theta multiplied by cos square theta over sine square theta minus cos square theta. So I cancel out, I get 1 over sine square theta. Sine square theta is also 1 minus cos square theta, so I get my answer. Okay. Then it says using the results of A and B, solve the equation this. Okay, I will have to think about how I can use these results. I have 1 over 1 minus 2 cos square theta here equals to 4 cos theta. 4 cos theta to 1 minus 2 cos square theta. So I'm ending up with something similar, I think. What I'm getting is 4 cos theta minus 8 cos cube theta. equals to 1. So if I move everything to one side, I get 8 cos cube theta minus 4 cos theta plus 1. This is similar to what I have here, 8x cubed minus 4x plus 1, such that, and it has been shown to be factorized to this 2x minus 1 and 4x squared plus 2x plus 1. 4x, 2x minus 1. 2x minus 1, 4x squared plus 2x minus 1. Okay, so it's been shown to get factorized to this. I'm just verifying if that is the correct factorization. Okay, so does this resemble this? Therefore, x has been replaced with cos theta. So I know that my expression also 8 cos cube theta minus 4 cos theta plus 1 equals to 0 will be factorized to 2 cos theta minus 1 into bracket 4 cos square theta plus 2 cos theta minus 1. Now, if you have never done add math, you would probably never have done cubic equations, okay? And they're not part of the P1 syllabus, which is why the question is telling you the factorized form itself. And you will use that factorized form to come up with a factorized expression and then solve. You'll say either this equals to 0 or that equals to 0. Cos theta equals to half. So quadrant 1 and quadrant 4. Quadrant 4 is out of the range because it just says 0 to 180. So alpha equals to cos inverse of half, which is 60 degrees. So quadrant 1 is just 60 degrees. Then I solve this using a quadratic for 2 and minus 1. So I'm getting cos theta equals to 0.309 and cos theta equals to minus 0.809. So again, quadrant 1 only, this time quadrant 2 only. Alpha equals to cos inverse of 0.309. I get 72. So quadrant 1 is 72.0. Okay, alpha equals to cos inverse of 0.809. I get 36. So quadrant 2 is 180 minus 36. Hmm. It's 144. And my answers are then 60, 72, and 144. Three answers. And I hope that was um, understandable. Okay, let's look at a functions question. It says function f and g are defined by this, where a is a positive constant. Find an expression for f inverse of x. Okay, so y plus a. I need a root, but when I put a root, I must decide whether a positive or a negative. So this domain tells me that the curve is going to the left. Therefore, there should be a minus outside. Okay, and I have then minus y plus a minus a f inverse of x. State the domain of the function f inverse. The domain of f inverse is the range of the original function. If you notice the range of the original function, now what is the range of the original? Range of fx. The function is x plus a whole square minus a for the domain x is less than or equals to minus a. What is its turning point? Its turning point is minus a comma minus a. So the function is looking like that. But I want only one side of the function, and that is the left side of the function. Why? Because my domain is pointing towards the left. This domain is pointing towards the left. So what is the range of this function? It's y is greater than or equals to minus a. This is, the curve is starting from minus a and then going up. So the domain of inverse should also be x is greater than or equals to minus a. State the range of the function f inverse. The range of inverse is the domain of the original, and that is simple. It's y is less than or equals to minus a. That was the question. Let's verify if our answers are correct. Yes, all the answers are correct. We'll quickly move on to the next one, given that a equals to 3.5. Solve the equation g f of x equals to 0. So let's first write down f of x. It's x plus 3.5 whole square minus 3.5. And g of x is 2x minus 1. So g f of x will become 2 times x plus 3.5 whole square 2 times x plus 3.5 whole square minus 8 equals to 0. Let's try solving this. 4 x plus 3.5 whole square. Now either you could take a root on both sides and say that there are two answers. One is with a plus and one is with a minus. So x is equals to minus 1.5 or x equals to minus 5.5. Now are both answers correct? My domain for f of x was x is less than or equals to minus a, which is minus 3.5. Okay, remember that a composite function always takes on the domain of the second function. So whatever values of x could fit inside f of x could also fit inside gf of x. So minus 1.5 doesn't fall in this range. You see, it's greater than minus 3.5. So this is going to get discarded. And I'll only have one answer, that is minus 5.5. Let's see if my answer is correct. Yes, it says, yeah. Okay, different ways of solving it, but you get the same answer. Question number 9. This is about the curve intersects at the points A and B. Find the coordinates of A and B. So this is about solving simultaneously first. This looks like a complicated equation. Why? Because this looks like a disguised quadratic to me. And there are lots of numbers there. What I'm going to do is I will try to bring the roots to one side. I will try to simplify the roots. 3 over root x, x power minus half means a root x in the denominator. 2 root x, and this is 13 over root x. So the first thing that I should do is I should bundle up the roots here. So I get, I don't know how much space I have. I think I have reasonable space. Let's move that to the left in case I run out of space. 10 over root x. Then we can take root x as this, and I take an LCM, so this multiplies by root x only plus 10, and then this cross multiplies, so I get 12 root x equals to 2x plus 10. Now how do you remove a root? Either you can do your substitution if you know that, or what I'm going to do is I'm going to square both sides. 144x 4x square plus 40x plus 100. Okay, let's try solving this. Let's see if we get the correct answer. This looks like a complicated equation to me. Yep, it looks fine. Okay, x equals to 25 and x equals to 1. Okay, I'm getting two answers. what I should always do is I should verify if they fit into the original question. I think both are going to right now fit into the original question since no negatives are involved. But I should insert them here and see if they balance the equation since there are two coordinates. I am pretty sure that one is A, the other is B. So this has to be A and this has to be B. I don't have the Y coordinates. Let's quickly find the Y coordinates. It's 3, 1 power minus half plus 12. So I get 15. So 1 comma 15 and 3 times 25 power minus half plus 12. So 3 over 5 plus 12. 12 point I think 6 plus 3 over 5. 63 over 5, which is 12.6. Yes. Okay, let's check if those answers are correct. Yes, they are correct answers. Let's move on. It says find the area of the shaded region. Now the shaded region is again trapped between two curves. So I'm going to say it's above minus below with the limits what? 1 to 25. Both have the same limits. They aren't different limits. Dx. Okay. So what is above? This curve is above. So I'm going to write that first. 3x minus half plus 12. And sorry, not limits. Below. What is below? 2x power half plus 13x power minus half. So I know that some powers are going to first get added. I'm not integrating right now. I'm simplifying it right now. The x, 16x power minus half minus 2x power half plus 12. Now I integrate it. When I increase the power by 1, it becomes positive half minus 2x half plus 1 becomes 3 over 2 plus 12x. I just have to insert my limits 1 to 25. So I'm going to keep it as it is and try to do it. Okay. Power 1.5. Okay. 160, 500 over 3, 300, 32, 4 over 3, 8, 24 over 3. Like a really big answer. Let's verify if that is correct. Uh, no, that doesn't sound right. Let me check my working, I think. I just need to check if my limits were correct. No, limits are correct. I think I may have messed up a sign right from the start. It's a problematic situation. Minus, so I have minus 10, minus 10, minus 10. Okay, let's check if we have the right answer now. minus 100 minus 20. There's a fair chance that I may have made another mistake somewhere as well. Yeah, there is some other mistake as well. Let me verify my mistakes first, and then I will see what more could have been done. I see no other error right now. Okay, lots of calculation mistakes. So I get 128 over 3. The rest of it was fine. I did mess up the sign right at the start. There's a difference. Well, it's just about turning pages. Right now I have to scroll back and forth, so I tend to make those mistakes. Okay, question number 10. The equation of a curve is this. Find the x-coordinates of the stationary point of the curve and determine their nature. So f bar of x. So 5 over 3, 4x minus 3, 5 over 3 minus 1 into 4 minus 20 over 3. 20 over 3, 4x minus 3 power 2 over 3 minus 20 over 3. 0. So 20 over 3 equals to 20 over 3. Okay, so 1 equals to 4x minus 3. Now, if you don't know, you can, sort of imagine, because this denominator 3 means the cube root. So I will have to cube the other side and root the other side. So when this power comes over to the other side, it becomes 1 power 3 over 2. So that I get 1 equals to 4x minus 3, 4x equals to 4. Uh, and I should get a plus minus, I think. Okay, let me just explain that to you. Let me just verify from the marking scheme first if that is the case, and then I'm going to explain that to you. Yeah, yes, I should get two answers. Okay, why? Because when you take a square root, okay, so let's do this step by step. When you convert this, when you cube both sides, you get rid of the power 3. So this becomes 1 4x minus 3 squared. Now when you put a root, you get both possibilities, plus and minus. So I get and determine the nature as well. Okay, so for x equals to 4, x equals to 1, for x equals to 2, and x equals to half. Okay, so I have those. Now I need to determine the nature as well. So I'll have to double differentiate this. I'm going to start off here and double differentiate it only. So 20 over 3. So 20 over 3 into 2 over 3. 4x minus 3 power minus 1 side, minus 0. So I get 40 over 9 for x minus 3 power minus 1 third. I need to find out whether they are maximums or minimum. So 40 over 9, 4 into 1 minus 3 power minus 1 over 3. That gives me a positive answer. So x equals to 1 is a minimum point. Okay, let's talk about this. 40 over 9, 4 times half minus 3 power minus 1 over 3. That should give me a negative answer. X equals to half is a maximum point. Was it asking me for the coordinates or just the x coordinates? Just the x coordinates then. Say the set of values for which the function is increasing. So the function is increasing when f bar of x is greater than 0. Okay, let's see where we can do that. So the idea is that I have to decide when 4x minus 3 whole square was greater than 1. Okay. And I got two values for x. Basically, when I solved this equation, I got two values for x. One was 1 and one was half. So if I decide when there's an increasing function, I'm going to make this small sketch and say that x is less than half or x is greater than 1. I'm basically asking you to tell me these areas. Okay, I think that should be the correct answer. Let me just verify. Yes, that is indeed the correct answer. Go on to the last question quickly. It says a set of points, this is this, respectively, where the line AB is perpendicular to the line BC. Given that P is less than 10, find the value of P. Okay, so if they are perpendicular, then their gradients should be negative reciprocals of each other. A, B, and C. Yes, so that's 3 into 14 minus, okay, they're not equal, sorry. M1 into M2 should equal minus 1. That's what I was thinking. It can't be that simple a question. 18 minus 7 over 14 minus 3. Yep, okay. Now you have numbers 3p minus 6. And I'm going to take this to the other side and say that minus 1 into 14 minus p over 18 minus 7 is 11. So 33 equals to p minus 6 into minus 14 plus p. Okay, 51 sounds like an odd sort of number that I'm getting here. P is equals to 17, B equals to 3, so I consider 3 in that. Okay. Circle passes through the points A, B, C. The equation of Find the equation of the circle. Okay. So if AB is perpendicular to BC, that means that there is a right angle at B. Okay, which means that AC should be the diameter of the circle. Is what is 6, 4 and 418, 1418, 6, 4 and C is 1418. Okay, so the midpoint of this must be the diameter of the circle. It's the circle property that I'm using. M gives me 10 comma 11. Okay, and then you find the distance. So I get 14 squared plus 8 squared. Root of 260. Half of that gives me the radius. Root of 65. Okay, so x minus 10 whole square, y minus 11 whole square equals to root of 65 whole square. Okay, that should be the equation of the circle that I have. Let me verify if that is the correct answer. Yeah, that is the correct answer. Then it says find the equation of the tangent to the circle at C, giving the answer in the form this. So the tangent to the circle at C is simple. The center is 10 comma 11 and C is 14 comma 18. So you find out the gradient first. of radius and O and C, and then you take the negative reciprocal of that because the tangent is perpendicular to the radius. And let's quickly do that. 18 minus 11 over 14 minus 10. So I get 7 over 4. So perpendicular it minus 4 over 7. I think that should be y minus y1 then, 14 and 18, m x minus f. Okay, so I get 7y minus 70, and 78 is 56, 126. So 4x plus 7y. 4 into 14 is not 56, minus 182. That is the end of this exam. I will see you with another paper in the next video. Thank you for watching.